All right, so the first lesson tonight is on section 8.1, and it's called Introduction to Relations. So before we get into the examples that are in your text, I want to talk about what a relation is. So by definition, a relation is a set of ordered pairs. Now, this set of ordered pairs doesn't necessarily have to be in ordered pair form, but just understand that if it can be written as a set of ordered pairs, it is a relation, a set of ordered pairs. Okay? X, Y in the coordinate plane. Domain. The domain of the relation is the set of the first components, which are the x's. So it's the set of x values that are part of the relation. And the range is the opposite. So it's the set of y values. Can someone tell me the page number for this in your book for section 8.1? 305. Okay, so on page 305 in your book. The example down at the bottom shows a mapping where you have one set here and one set here. And it's a set of A, B, C. And then over here it's 1 and 2. And A goes to 1, and B goes to 1, and C goes to 2. And they ask us to find the domain and the range. I usually just abbreviate them with capital D and capital R and then a colon. So your domain is the set of first values. If it's not in XY form, which this clearly is not in XY form, you have first and second, okay? So this is your set of first values. So your domain is A, B, C. And we usually put them in braces, A, comma, B, comma, C, comma. And the range is 1, 2. If I asked you to write the relation itself, you would write the set of ordered pairs, A, comma, 1, comma, B, comma, 1, comma, C, comma, 2. Now you can see at the bottom of page 305, there's also a graph there for you, isn't there? Okay? The graph is a set of ordered pairs as well. So the domain of that one, we're just going to look at it together rather than me put it up here, but the domain would be -4, -2, 0, and 2. Does everybody agree with that one? I'm on the bottom of page 305 looking at the ordered pairs. So just the x coordinates, so just the domain, -2, -4, 0, and 2. Is that correct for the domain? What about for the range? What's the y coordinate for the one that has the x coordinate of -4? What's the y coordinate? 3. And then 3 is the y coordinate for the next point, isn't it? You don't list it twice, you just write it one time, okay? And then 0, and then the y coordinate for the point that's on 2 is also 0, and then the one for -4 is, the second one for 2 is -4. So you would just list the y coordinates, and if there are any repeated, you don't write them twice, okay? Or don't write them more than once. Okay. What if I gave you a graph that looks like this? And I said, what's the domain and what's the range? Now, I'm telling you that this V-shaped graph is a relation, okay? So it's a set of ordered pairs. Now, it's not written in ordered pair form. It's a graph that is made up of ordered pairs, correct? Okay, so what's the domain of this? Well, what you have to do is you have to carefully look at the x-axis. So I'm going to highlight it. I'm going to look at it really carefully. And when you're talking about domain and range, you can kind of list things. If you're listing numbers, you can list them in any order. But if it's an infinite amount of numbers, then you need to write it from least to greatest. Okay? What is the least most x value that is a coordinate of a point on this relation? Negative 2 is the least x value. Does everybody see that? And then as I moved toward positive infinity, which would be way out here, these x values, I just continue to have points with x values on it, right? Yeah, I actually have 2 points on it for every x value that's on the x-axis from negative 2 creeping toward positive infinity. Okay? So you are going to write that negative 2 to infinity for your domain, and you're going to write it in what is called interval notation. Negative 2 has a closed circle on it, so it's included with a bracket. Now, did we talk about brackets and parentheses already? I can't remember. Okay, if the point is enclosed, like closed-in circle, then that means the point is part of the graph. Okay, so negative 2 is part of the graph. If there were an open circle here, it would mean that negative 2 is not part of the graph, but every teeny tiny minuscule little decimal infraction that's right up next to negative 2 is. Okay, so this means negative 2 is included. To include it in interval notation, you use a bracket. Okay, and then you put a comma, and then it's creeping toward the domain. All of the x values that are on this graph somewhere, either up or down, are going to keep creeping toward positive infinity. Does everybody agree with that? Because this graph goes on and on and on forever and ever and ever. So positive infinity looks like this. Now you can never enclose or include positive infinity in your interval notation, so you just have to put a parentheses around it. Did we talk about interval notation early on? I can't remember. I teach this a lot, and so I can't remember who I've spoken with it about or not. Okay, so this is the way that you write an interval of numbers in a condensed notation. Okay, now you know a notation is just a way to write something. So a long time ago, secretaries used to sit and take shorthand. If you ever watched like an episode of Bewitched or some of those old shows where they were set in an office, there was always a secretary, and she would always sit and she would take shorthand. Well, that was a notation for what the man was, he was always a man too, was saying to her. Okay? It was. And she was always cute. But that was the notation for it. So it's just a way to write something. So this is a way to say my domain contains every number from negative 2 to infinity. Okay? Now what about the range? So what y values are on this? You can pull any point you want to. You can look at any point on here. This is made up of infinitely many points, isn't it? With decimals and fractions or however you wanted to write. Teeny tiny little numbers, great big numbers, they're on there. So as you look at the y-axis here, the y-axis, the numbers that coordinate to points on this sideways V are going to be part of your range. okay? So if I asked you, for example, just give me, let's pretend like we knew this point was 1, 5. So one of the range values would be 5, right? But this point right here has a range value of 4.9, and this one has a range value of 5.127, and this one has a range value of 6.09. Every number on this y-axis is going to somewhere correspond to a point on that graph, isn't it? All of these numbers, all these in here, 0, 1, 2, 3, 3.2, it's going to be somewhere on this graph. So the range, because it contains all the numbers on it, is from negative infinity to positive infinity, because it runs up and down. So I can go as low as I want to down here on this y-axis, and it's going to correspond somewhere to a point on that graph. I can go as high as I want to, and somewhere it's going to correspond to a point on that graph, because that graph goes on forever. So it's from negative infinity to positive infinity. Do you have any questions on what a relation is? Okay. There is another example that I want to show you that's going to be a little bit difficult for me to draw, but I think I can sketch it enough so that you will catch on to it. I hope, anyway. So each one of my little tick marks is going to be 1 unit, okay? And they're supposed to be equally spaced apart, and they're not. I apologize, but just use your imagination there. All right, so I have this graph that is made up of what looks like stair steps almost. So there's a point at -4, -2, and it stretches over to -1, -2. Oops, this one has an open circle on it. Okay, and then I have one up here at -1, 1 with a closed circle, and it's going to stretch across to 2, 1 with an open circle. And then it starts at 2, 3, and it stretches across to 5. Now, chances are this is the first time you've ever seen a graph that looks like this. This graph is, it falls under the umbrella of a piecewise function, which you'll learn more about if you have to take higher maths. And it is also the sub name of it, sort of underneath this big realm of piecewise, is that it's called the greatest integer function, or a step function, because it looks like stair steps. So we need to analyze the domain and the range of this function. Now this is going to be really interesting, because you've got to look at it carefully. We're going to look at the x-axis first, because our domain is the set of x values that are on this function. Okay? So I'm just going to scan the x-axis first and see where it relates to points on this function. Well, I keep calling it a function because I know it's a function, but we're going to call it a relation. So where does it relate to points on this relation? Okay? We're going to start from the left and go to the right, because we always go least to greatest. So this, by the way, this relation is made up of these three segments. Okay, so when I say the relation, I'm speaking of these three segments, these three steps. Okay? What is the least most x value represented as a point on this relation? -4. It's right here. Is it closed in or open? Closed in, so that means it's including -4. Okay? Then as I look across, I reach and I get over to -1. And -1 has an open circle on it. So -1 is not included in this segment of the relation, but as I look up to the next segment, it has a closed circle. So it is included there. Okay? So far, I'm from -4 to -1, included in both. Then I'm going to keep looking to the right. Creeping over, I get to 2. Same situation. Open circle at 2 on this segment, but this third piece of the relation has a closed circle at 2. So it includes 2 as well. And then it gets on over to, this is the number 5. I should have written that in black, but this is 5. Okay, so it gets over to 5. And 5 has a what? So that means it's not included, right? So my domain stretched from every tiny little fraction between those integers all the way from -4 to 5. It does not include -5, so I use a parentheses, but it did include -4, so I use a bracket. So you're just looking at the x values that correspond to points on those segments. Okay? Now we're going to look at the y values. So we got to look up and down now. Okay? I'm still looking at this segment, which stretches sideways, but I got to ask myself, what are the y values of the points on this segment? It's your turn. I mean, I said I was going to ask myself, but I was really asking you. So, what are the y values? There's only one, isn't it, on this whole segment. Every point on that segment has a y value of what? -2. Do you see that? I didn't mean to put that blue dot there. But look across. Aren't all those ordered pairs going to have a y value of -2? Okay, so we got that. All right, now, I move on up. All of the ordered pairs that make up this segment have a y value of what? +1. That's it. Every point on this segment has a y coordinate of 1. Okay? Look on up. What about this one? Those are all what? 3. So, the range is not an interval. It's not a continuous interval of numbers, is it? It's 3 numbers, and they are -2, 1, and 3. This is a list with commas between it. This is an interval saying it starts here and it ends here. And it includes -4 and it doesn't include 5. Okay? Any questions? Are y'all really bored with this, or it's just mind-blowing, or what? I'm trying to figure out what where are we feeling about this. Long Labor Day weekend. Okay. All right, well, that's all of 8-1. So, all right, so we are going to I was going to try to open up a new one, but I'm afraid it's not going to work. All right, so we're moving on to functions. So So a function has a definition that you also need to be very familiar with. A function, and I will abbreviate that FCN if I ever have to write it a bunch, okay? A function is a special relation. Oops. It's a special type of relation in which each element in the domain is paired with exactly one element in the range. Now that's textbook definition. So I'm going to give you Mrs. Hopkins' definition in a minute that always helps the students get the right answers, okay? Because this is a lot of mathematical jargon that you just learned. So it might be hard for you to understand that, and then again it might not. What I always tell my students is no x is repeated with multiple y's. So if I gave you a set of ordered pairs, and I said, is this a function? Is this a function? What's the answer? FCN question mark. Is this a function? Is there an x paired with more than one y? What about the x value of 6? It's paired with a 3, and it's paired with a -1. Therefore, it's not a function. Okay? Because the x value is repeated with multiple y's. Okay? It's a special type of relation in which each element in the domain is paired with exactly one element in the range. Well, this element 6 in the domain is paired with 2 elements in the range, isn't it? So it doesn't meet the textbook definition, and it doesn't meet that one either. All right, what about this one? Is this a function? You're only looking for x's to be paired with multiple things. So you can have repeated y's and it still be a function. You just cannot have repeated x's. So is this a function? Yes. Good. All right, what about if I gave you a mapping and asked you if it was a function? Remember, your first values are always your x's and your second ones are always your y's. Is this a function? No, because the x value of 3 is paired with 3 different range values. So the one value of 3 in the domain is not paired with exactly 1 in the range. So this is not a function. Okay? Now, you can also look at graphs and determine if they are a function by what is called the vertical line test. Okay? So I've drawn two graphs up there, and I'm asking you, are these functions? The way that you use your vertical line test is you draw or you lay your pencil across, whatever. You put a vertical line through it, okay? If the vertical line crosses it only one time, if every vertical line you can put through it crosses it only one time, then it's a function, because that means there aren't any repeated x's. But if it crosses it twice, it's not a function, or 3 times, or whatever. So as I draw the vertical line through this one, sorry, it's a little crooked, but this has a y value of 1, that point on the circle, and that point on the circle also has a y value of 1. This is not a function. The vertical line crossed it twice, didn't it? Okay? But as I draw vertical lines through this parabola, which you don't know the name of that yet probably, every time it crosses it only what? One time. So this one is a function. Okay? Now we're going to talk about function notation. Again, notation is a way that you write something. Okay? So function notation is when you see f of x. And it literally means a function f evaluated at x. This is notation. So it's a way to write something. When we're talking about linear functions, f of x is y. It's also when we're talking about other functions as well. So f of x is the same thing as y. So used to, you might see y equals 2x, which would be an equation. And what you are doing now is you are saying the function of x is 2 times x. Okay? Those two things mean the same thing. When you're given an equation in function notation, oftentimes you'll be asked to evaluate that function for different values. So we're going to start with, let's evaluate f of negative 2. That says let's evaluate the function f at negative 2. So you're going to put negative 2 in for x, just like they did. So 2 times negative 2 is what? Negative 4. This was a problem they gave me. That's the first example, building from this function that they gave me at the top. Okay? The next one is, let's do f of 0. So evaluate the function f at 0. That means put 0 in to the original function up here where you see the x. 2 times 0 is what? What's 2 times 0? Okay? So the function evaluated at 0 is 0. So that's just the second problem. So on page 312 in your book, there's tons of those you can look at. I'm not really sure why they gave you the graph there because they didn't ask you to graph it, but we could graph it. Those would be ordered pairs. So instead of having x, y ordered pairs, you have x, f of x ordered pairs. It's f of x. That's how it's read. F, the word of, O-F, and then x. A lot of times your functions will be called g and h. Those are very common function names. So f of x, g of x, h of x. Just common ones. But it could be anything. They will tell you in the directions it's a function. Evaluate the function f of x equals 2x for the following values. Okay? Now, some students think that means f times x. That is not what that means. So if you try to divide both sides by f, you're going to really make a mess. Don't do that, okay? This means a function named f evaluated at x equals 2 times x, okay? I know it's a lot of nitpicky notation stuff, but you just have to be ready to work with it. All right, if I said f of negative 10 equals 11, and I tell you that y equals f of x, and I said, what is an ordered pair represented by this expression? What is the ordered pair? Represented by this expression? I'm just going to say represented here. So if we go back over here, x is the number you were plugging in, right? And f of x is like your y value. So the ordered pair here would be negative 2, negative 4. The ordered pair here would be 0, 0. So if I come back over here, what's the ordered pair of this one? Now this problem doesn't have anything to do with this one, okay? They're not the same problem. I'm just building from what we just looked at here. So what's the ordered pair represented with this one? What's the x coordinate? Huh? Negative 10, and the y coordinate is 11. F of x equals 11. This number is your x. This number is your y. Okay, I'm going to give you another one, another weird one. I'm going to tell you a new function. So g of x equals x squared plus 4. And I'm going to ask you, so this is what you're given, I'm going to ask you to do g of t. G of t. What would we do with that t? Okay, let's look over here. I did f of negative 2, and I put negative 2 into the function everywhere I saw the x, right? I did f of 0, so I put 0 into the function where I saw the x. So what if they asked me to do it for a variable? Follow the same concept. Put t in for x, just like you would if they had given you a number. So this would be t squared plus 4. What if I said do let me give you another problem. So this is another problem, starting another one. H of x, this is your function that you're given, equals 1 over 5 plus x. And I said, I want you to find, or find is probably not the right verb here, but we're going to use it. Find h of x plus 3, period. So what do I do with the x plus 3? Y'all, same concept, broader substitution maybe, okay? When they gave me a number, I put it into the function where I saw the variable. They had put it here for x and asked me to evaluate it, and so I put it over here for x, right? When they gave me a variable in place of x, I simply put the variable in place of x. Well, now they've given me a binomial expression in place of x. So guess what you're going to do? You're going to evaluate the function h at x plus 3. So it's going to be 1 over 5 plus, instead of x, you're going to put what? X plus 3. And then you're just going to bring down the left-hand notation, and that's 1 over x plus 8 when you add your two like terms together. Any questions? Okay. All right, I'm going to draw a graph the best I can. I wish I had an Elmo so I could put this up for y'all. And we could talk about it that way. It would be the best. So that point is at negative 2, 2. All right, so this is what the graph looks like. They don't call it, they don't give you an equation for it. They just say, this is the graph, y equals f of x. And by the way, I have seen this here recently in a lot of different lessons and textbooks and resources. This is some notation that they are expecting you guys to really know that y is f of x and that this is the function that we're talking about. This, I'm going to write the ordered pairs on here because I'm not on graph paper and it's pretty sloppy. So this ordered pair here is the ordered pair negative 2, 2. This crosses here the x-axis at negative 3, 0. So I'm just going to kind of put that ordered pair right there for you. So you'll see that that's where it crosses. This one is at negative 1, 0. This one is at 1, negative 4. This crosses the x-axis at 3, 0. That's really sloppy. And then this one has an open circle at 5, 4. And they say the graph of y equals f of x is shown here. Find the following. Find was the right verb. F of negative 2. Okay? So I'm supposed to look for what f of 2 is negative 2 is equivalent to on this graph. So you have to relate this to what you just learned up here. You go, well, this is the x value. It's always f of x, right? And it tells you here y equals f of x. So f of x. So the x value is what? Negative 2. So you're going to look on your graph and go to negative 2 on the x-axis. And then you're going to go up or down to the point on your graph. So I go up, and right there is the point that corresponds to the negative 2 in the x. What is the function value at that point? That's your y value, okay? Or your f of x value, because remember, y equals f of x. So what is it? 2. Okay? Let's do f of 5. So we're just going to do a few. We're not going to do everything that's on here, but a lot of them. All right, see if you can find that one yourself. You're probably tempted to say it's 4. Are you tempted to say it was 4? If I go over to 5 and up, it's at 4, right? But what? It's not included. The circle is open there. So f of 5 is undefined because 4 is not included. There's an open circle there at the point 5, 4. So you see how that works? You're looking for the y coordinate that goes with the x coordinate. All right, let's talk about the domain. What's the domain of this function y equals f of x? So I'm looking for the x coordinates that make this function. Okay, what are the x values on this function? Well, if I go from left to right, well, this thing goes forever and ever and ever down, which means that these x coordinates that go into negative infinity are forever going to be on that. Is that correct? So the x coordinates start at negative infinity. And then as I move to the right, they just keep getting bigger and bigger and bigger. The x-coordinates keep growing. They stop here, don't they? What is the x-coordinate that it stops at? What's the x-coordinate of this final point? But it doesn't include 5, does it? It includes every little tiny little decimal right up next to 5, which there are infinitely many of them. Right? You can always add another decimal place. So you're going to put a 5, but you're going to put a parentheses to say it does not include 5. Okay, let's do the range. Same concept. So as I go left to right, I read the graph left to right. What is the least y value on this graph as it continues to go down, 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 down? So here's my y-axis. It's going to keep on having points on it, isn't it? As I take this down, 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 won't these y values just keep getting more and more negative that correspond over here to the points on the graph? So it's at negative, what's the least y value you would say? Negative infinity, because there's not one, right? It goes forever into negative infinity on the y-axis. And then let's keep going. So we move up, the y values, the y coordinates are getting bigger because we're moving up. Then they start going back down again, but that's okay, no biggie. And then they start getting bigger until they get to the y value of what? 4, the range value of 4, and it stops, but it doesn't include 4. Sometimes interval notation, which is what this is called, can look like an ordered pair. And that's okay. All right? All right, so we are going to look at a graph, and this is an odd placement for this example. There's nothing to build on from it. It's just look at the graph and estimate the x and y intercepts. So I'm going to simulate this. Best I can. I don't have graph paper, so it's really, they're not very pleasing to the eye. So they give me a graph and they say, approximate the x and the y intercepts. So what are the x-intercepts here of this graph? That would be every place that it crosses the x-axis. Crosses the x-axis here. What's that ordered pair? Thank you. -3, 0. Crosses the x-axis here. What's that ordered pair? -1, 0. Crosses the x-axis here. 2, 0. Then we have our y-intercept. Okay, I only see one y-intercept. Where does it cross the y-axis? At the point 0, what? -3. Now it is important that you take note and that you put it in your file, especially if you have to go further in your math studies, that all x-intercepts have y-coordinates of 0 and all y-intercepts have x-coordinates of 0. Now that makes perfect sense if you're looking at a graph, but if you're just talking about them, sometimes we forget those things. Now the last concept we're going to talk about is using algebraic methods to determine the domain of a function. So use algebraic methods. I say the last concept in this section. So the first one I want to look at is f of x equals x plus 3 over x minus 2. So we're not going to graph this one and look at the picture to determine the domain. We're going to analyze the function. We're going to immediately recognize that the function is a fraction, right? And then bells are going to go off inside our head telling us, ooh, fractions can't have denominators of 0. So your domain will be every real number except the ones that cause the function to be undefined. So let's write that down somewhere. I'm not going to write it up here, but you write it down. Your domain will be every real number except those which cause the function to be undefined. I'll say it again. The domain will be every real number except those which cause the function to be undefined. If the function contains a fraction, then you must exclude any values which would cause the fraction to have a denominator of 0, because that's when fractions are undefined. So, as you look at this function, you only have to deal with the denominator because it's a fraction. So, you have to think x minus 2 cannot equal 0. Whatever the denominator is cannot equal 0. And then you solve this equation by adding 2 to both sides. So you solve it for x, and you get x cannot equal 2. So there's two ways you can write this. I like interval notation, but I'm not sure that they're not going to throw this set builder notation at you. So you can write it as the set of all x such that x cannot equal 2. That's called set builder notation. Or you can say it's all real numbers except 2. So that means it's from negative infinity to 2, don't include 2, union with 2 to infinity. So this notation is interval, and it excludes only 2. Every other number in the whole entire world is on that except 2. Okay? This is easier, but I'm not sure which way they're going to ask you to write it. This U is a union symbol. So you're saying I'm uniting this interval with this interval as my answer. And this interval contains all the numbers from negative infinity to 2, and this interval contains all the numbers from 2 to infinity, but neither one of those intervals contain the number 2. If I gave you another one with the same instructions that had a radical in it, so h of t equals the square root of t minus 3. Again, using algebraic methods to determine the domain. Those bells should go off ding, ding, ding in your head. Oh my goodness, I can't take the square root of what kind of number? A negative. You can't take the square root of a negative number, can you? Now, you're going to learn eventually about imaginary numbers, which is a way to represent square roots of negative numbers, but you're still not taking the square root of a negative number because it's imaginary, okay? So right now we're just going to go, we can't do it. So, negative numbers are, how could I call negative numbers? Like, if I was looking at a number line, where would my negative numbers be? On the left side. Good. Left side of what? 0, right? So your negative numbers are to the left of 0. So technically speaking, they are less than 0. Is that correct? So I need to say, I need to think, what's underneath the radical has to be greater than or equal to 0. Is that a true statement? What is underneath the radical, whatever it is, in this case it's t minus 3, has to be greater than or equal to 0. My domain in this case will be my t values, not my x values, because I don't have an x. Okay? So, as long as t minus 3 is 0 or bigger, I am defined. Is that correct? My function is defined, I should say. Okay, so we're going to solve this little inequality. All you have to do is add 3 to both sides. And you get t has to be greater than or equal to 3. So my domain will be the set of all t such that t is greater than or equal to 3. That's one way to write it. Or you can write it in interval notation. It starts at 3, and if it's greater than 3 and never stops, that goes to what? Positive infinity. 3 is included because 3 minus 3 is 0, and I can take the square root of 0. It's 0. Okay? Any questions? Okay? We are going to pause for a moment